All right, so real quickly, let's finish this up here. So volume is equal to 4/3 pi r cubed. Our radius here is 3. So I'll plug that in for the variable representing the radius, which is r. So we got 4/3 times 3 cubed. So 3 cubed, or 3 times 3 times 3 would be 3 times 3 is 9. 9 times 3 is 27. So I get 27 here. All right, I'm going to do first 27 divided by 3, because remember, when we multiply our fractions here, this is the same as 4/3 times 27 over 1. So I'll cross cancel here. 27 and 3, the greatest common factor these guys share is 3. So 3 divided by 3 is 1. 27 divided by 3 is 9. And now I just have to do 4 times 9, which is equal to 36. So I get 36 pi. And then if we want this answer not in terms of pi, we can do 36 times pi, which is equal to approximately 113.1. So this is in terms of pi, and this is not in terms of pi here. Alrighty, hopefully everybody's getting the hang of this here. It's very similar to cones and cylinders. If you felt good on those, you should feel good on these as well. All right, we got a few practice problems here, so I'd like you to first try these out on your own and then check my answers after. All right, so if we have a sphere with volume 30 pi, what is the radius? So I'll just plug this into my formula here. I'll write it up at the top here, pi r cubed, and we have a 4/3, oops. All right, so if my volume is 30 pi, I'll replace the v with a 30 pi because that's the variable for v, and that'll be 4/3 times pi times r cubed. All right, so let's just do some division here, right? Hopefully we can see that our pi's will cancel. We could just divide that on both sides, and we're left with 30 is equal to 4/3 r cubed. So we have to divide both sides here by 4/3. Dividing by 4/3, if we remember our keep, flip, change rules, this is whatever number here, say x. This would be x times 3 over 4, right? Keep the first fraction, flip the second fraction, change to multiplication. So we're actually going to multiply both sides here by 4/3. All right, so 30 times 3/4. We've got a greatest common factor here of 2, so we'll divide both of these by 2. All right, so 15 times 3 would be 45, and then divided by 2. So I get, I'm just going to have to keep writing here, I guess. 45 halves is equal to r cubed. All right, so the way we get rid of a cube number like this, it's pretty similar to the way we get rid of a squared number, except now we take the cubic root. And this is really going to be one where you're just going to have to go to your calculator here, which now that I'm looking at my calculator, I don't know how I use that button. Uh-oh. Oh, there it is. All right, so we'll find the cube root of 45 divided by 2 equals, I'll take a second, root of that. That's going to be approximately 2.8 is equal to r. So after we use our calculators and take the cubic root of 45 halves, we would get approximately 2.8. All right, so let's do this one here now. A sphere has radius 6. What is the volume? So we got 4/3 pi r cubed. So we have v is equal to 4/3 pi 6 cubed. 6 times 6 is 36, and 36 times 6 is 216. So we're going to get that 4/3 pi times 216. So we're doing 216 times 4/3. So I'm just going to first do 216 divided by 3, see if that does anything neat here. It gets us exactly 72. Cool. So we get 72 here. So that means I could cancel these out. We got 172. And then 4 times 72 is equal to 288. So I get 288 pi. If I lost you there a little bit, it's really simple. All I did was just multiply those numbers together there in my calculator. Alrighty, so quickly go to our conclusion. Don't forget, you guys are going to have to do this one on your own. Just use mine as an example here. So today we talked about volumes of the spheres. We kind of used that to find some missing parts. Hope you guys found this useful. Don't forget to take notes, and I will see you all in class tomorrow. Peace out, everybody.